Good day everyone. I am GB Sobron Butata of BSed Science 3B, and today I will be discussing about electron microscope. So what is electron microscope? It is a type of microscope that uses a beam of electrons. When we say beam of electrons, it is a stream of negatively charged particles. So this electron microscope used to magnify and visualize very small objects, structures, and biological specimens at high resolution. Unlike optical microscopes that use visible light, electron microscope used a focused beam of electrons that has a shorter wavelength, allowing for high magnification and better resolution. So we have here Hans Bosch. He invented the first electromagnetic lens in 1926. And although he allegedly filed a patent for an electron microscope in 1928, he did not construct the microscope. Next, we have here Ernst Ruska and Max Knoll. They are a physicist and an electrical engineer. They are from University of Berlin, who created the first electron microscope in 1931. So how does electron microscope works? So as far as we know, electron microscope works by using beam of high energy electrons instead of light to create an image of a sample. So it have two types. These are transmission electron microscope or the TEM and scanning electron microscope or SEM. So let us start with the transmission electron microscope. So it works by a passing beam of electrons through a thin specimen. As the electrons pass through the specimen, they interact with the atoms and molecules within the specimen, creating an image of its internal structure. The resulting image shows the specimen's internal structure, composition, including the location of an atom, crystals, and biological structures. So here's an example of an image of a specimen under TEM. Now, let us move on to its other type, the scanning electron microscope or the SEM. SEM use a beam of electrons to scan the surface of the specimen. The electrons interact with the atoms on the surface, creating a three-dimensional image of a specimen's surface topography. SEM images provide a detailed view of the specimen's shape and structure, allowing researchers to study surface features such as ridges, bumps, and pores. So here's an example of an image of a specimen under SEM. Now, let us proceed to the SEM versus TEM advantages. So in comparison to TEMs, SEMs cost less, take less time to create an image, require less sample preparation, accept thicker samples, and can examine larger samples. So in comparison to SEMs, TEMs create higher resolution images, provide crystallographic and atomic data, create 2D images that are often easier to interpret than SEM 3D images, and allow users to examine more characteristics of a sample. So for the summary of this lesson, electron microscopes are commonly used in fields such as biology, material science, and nanotechnology to study the fine structure and properties of materials and biological samples at the nanoscale. With their high magnification and resolution capabilities, electron microscopes have been instrumental in advancing our understanding of the molecular and cellular basis of life, and have contributed significantly to the development of new materials and technologies. So it have two types, the TEMs and SEM. Transmission electron microscope provide high-resolution images of the internal structure and composition of specimens, while SEM, or the scanning electron microscope, provide detailed view of the surface topography of the specimen. So overall, electron microscopy is a powerful tool for visualizing and understanding the microscopic world. While it has its limitations and challenges, its unique capabilities have been instrumental in advancing a wide range of scientific disciplines from biology to material science. So that's all for my report. I hope you've learned a lot. Thank you.